let's find the tangent line for a specific curve at a specific point. So what we're given is a space curve that can be parameterized and described by this position vector. And we're given this point, 1 square root of 3, 1. And we want to find a set of parametric equations that goes through them, but we also want to find the unit tangent vector t of t. So notice in this particular case, we're not finding t at a particular value for this part of the question. So we're going to have to go through the entire process to get it. Well, let's just get to it. So remember that t of t is r prime divided by the magnitude of r prime. And anyway, I was going to say something else, but we'll get to it there. So let's find r prime. R prime of t is 2 cosine t, negative 2 sine of t, and power rule, that becomes 8 sine of t times the derivative is cosine of t. And if you remember a little bit from trigonometry, you'll recall that we can rewrite this piece as that. It's not that important, but nice to have a little refresher. So the next big thing is we got to get that magnitude. So that's going to be a little more tricky. So if I want to get the magnitude of r prime of t, then I'm going to square this one, and I'm going to square this one, and I'm going to square this one, and then I'm going to take the square root. So then that gets me 4 cosine squared t plus 4 sine squared t plus 16 sine of the fourth of 2t. I'm sorry, sine squared 2t. And that's all under 1 square root, but that is 4 cosine squared t plus sine squared t plus 16 sine squared 2t, which, remember that identity is just 1. Giving us 4 plus 16 sine squared 2t. Now I can factor out a 4 here and get 1 plus sine squared 2t. And then finally I get 2 square root 1 plus 4 sine squared 2t. So all that work to get that magnitude. But remember, we have to plug it into this equation, so we have to take this vector, or rather, sorry, this vector, and divide it by that quantity. So if I take this element and I divide it by that piece, the 2's cancel, so I end up with cosine of t 1 plus 4 sine squared 2t. I take this piece and divide it by that quantity. The 2's cancel, so I end up with negative sine t over the square root 1 plus 4 sine squared 2t. And then I take this quantity, divide by that, and I have 2 sine 2t over square root of 1 plus 4 sine squared 2t. So that's a lot. But that's the unit tangent vector. So we have gotten there. And you could take this magnitude to determine whether or not you think it really is a unit vector. It is. So then we want to find this set of parametric equations. We have a point, so we have to find values of t that make this position vector land at that point. Well, to get 1, 2 sine of t is equal to 1, so sine of t is equal to 1/2. And if you remember on the unit circle, that happens at pi over 6 and 5 pi over 6. So if we use, let's just guess and say pi over 6. So pi over 6, sine of pi over 6 is 1/2 times 2 is 1. Cosine of pi over 6, first quadrant, is square root of 3 over 2 divided by 2 is square root of 3. And sine of pi over 6 is 1/2, so sine squared is 1/4 times 4 is 1. So it looks like our t value is pi over 6. So why is that helpful? Well, we're going to use that with r prime. So r prime at pi over 6. So again, cosine of pi over 6 is square root of 3 times 2. So that gets us square root of 3. Sine of pi over 6 is 1/2 times negative 2 is negative 1. And this is for sine of 2t. So if t is pi over 6, 2t is pi over 3. Sine of pi over 3 is the square root of 3 over 2 times 4 is 2 square root of 3. So these will now be my direction numbers for the vector. So I have a point and I have these direction numbers. So I simply have to fill in the parametric equations. X equals 1 plus square root of 3t. Y equals square root of 3 plus, or in this case, minus t. And z equals 1 plus square root of 3t. And that's how you find both the unit tangent vector and a line tangent to the curve at the specified point.